Good morning, everybody. So,
Morning,
Good
sir.
morning, sir.
good morning, good morning. So, let's go for next topic of very important topic. This is the hydrogen atom, and we will just try to understand conceptually. I will not go to unnecessary derivation of hydrogen atom, but we will discuss all the physics, and we will just solve. We will just try to understand all these things with help of problems. So, but yes, I will start from the scratch actually, and I will theoretically discuss what we are going to do. But because solving the hydrogen atom is all doing the series solution, this is not required for your examination. If you want, I can give you handwritten notes. That is not issue. But unnecessary going to solve the series and solution, it's not a unnecessary. You are wasting the time actually. So let's go for what is hydrogen atom, how we can try to understand it, and what is algorithm of solving the this particular thing with this particular system. We will try to go for this, and then we will go for problem. The problem is most important thing, and the application of hydrogen atom, we will just try to go for it. So in general, the classical hydrogen atom is a electron is revolving about the proton, and it is revolving about the proton into the allowed angular momentum, which mvr is equal to nh cut, given by the Bohr-Sommerfeld theory or Bohr quantization rule. You have learned this thing into your +2 level or all this thing. But that is the semi-classical theory. Here we have to go for the quantum mechanical theory. And for this theory, we have to solve for the potential. The potential is all about VR, and this is attractive potential between electron and proton in a nucleus. So this will be E square upon 4 pi epsilon naught r. So we have to solve the basically Schrodinger wave equation for this potential. And please, you can remember that this is nothing but the central force problem. So if it is a central force problem, then Hamiltonian must be commute with the angular momentum. So if Hamiltonian is going to commute the angular momentum, so the eigenfunction of h and the eigenfunction of L square can be simultaneously measurable. And we have seen into last class also that how this will works. So what we have to do, I have the wave function, and we have to solve this problem into a spherical polar coordinate. Excuse me. So we have to solve this thing into a spherical polar coordinate. What we have to solve? We have to solve h psi, and this will be function of r theta and phi is equal to E psi r theta and phi. And this h is nothing but the kinetic energy. This will be h square up minus h square upon 2m del square psi plus potential energy. Here is the potential energy we have, minus E square 4 pi epsilon naught r psi with the minus sign would be equal to E psi. And you know, from this particular concept, what we can do, we can write psi r theta phi is nothing but the radial part of wave function into ILM always. And last class, deliberately we have solved one problem completely, that how this thing is going to work. So actually what we have to do, so actually what we have to do, we will again put this equation into this particular differential equation, and this is nothing but the Laplacian of a spherical polar coordinate system. And finally, we will get the radial part of wave function. You remember all this thing we have done into last class, so I am not doing unnecessary this thing actually. So what will be the radial part of wave function? The radial part of wave function is h square upon 2m, and this will be d square r upon dr square plus 2 upon r dr upon dr plus you have centrifugal term L into L plus 1 h cut square upon 2 mr square minus E square upon 4 pi epsilon naught r, and the radial part r is equal to ER. So actually what we have to do, we have to solve this differential equation. And solving this differential equation, again what we have to, and this is nothing but the translation kinetic energy, this is nothing but the rotational kinetic energy, and this is potential energy. So what we have V effective as L into L plus 1 h cut square upon 2 mr square minus E square upon 4 pi epsilon naught r. So this is the all stuff. And how you will solve this all thing? You will solve this thing as just putting r as u r by r. And finally, I have one differential equation minus h cut square upon 2m and d square u dr square plus we have to solve L into L plus 1 h cut square upon 2 mr square minus E square 4 pi epsilon naught r ur is equal to EU. And after, when you are going to solve this particular thing, you will solve for, first you will get the approximate solution, r is smaller than 0, r is very greater than 0, and then you will just go for the series solution method. That will be unnecessary, take your time. So I am just writing the direct result what we are getting here. So what will be the direct result? The direct result, what you have to understand, only this thing, not all this differential equation. This is not part of this thing. This all solving the problem. Nobody will ask how you are going to solve this hydrogen atom. But yes, it's a very lengthy and unnecessary, it will take time. So what you will get? You will get the radial part of wave function is nothing but one very famous polynomial, and that polynomial is LNR. And this is basically known as Laguerre polynomial. And energy you will get En is equal to, this energy is nothing but the energy of hydrogen atom, and that thing you will get as minus m upon 2h cut square, and this will be E square upon 4 pi epsilon naught whole square 1 upon n square. And once you will, and m is nothing but the mass of electron, E is the charge of electron, and when you are going to calculate all this thing, you will get this energy is nothing but minus 13.6 upon n square. So this is the radial part of wave function, and this is all about your energy. And what will be your total wave function? The total wave function you can write psi n l m, and this will be actually the radial, and this you can write Rn. So this will be radial part of wave function into y n l m theta and phi. And what is this thing? This thing is nothing but the Laguerre polynomial. And this thing you can write Laguerre polynomial NLR y lm theta phi. So it's a very complex, it's a very complicated function. Laguerre polynomial is itself very complicated function, but at least you have to remember one or two function. And what is value of n? The value of n is started from 1, 2, 3, and so on. The L will be go to 0, 1, 2, 3, and n minus 1. This is the selection rule. And m will be, you know what is value of n is minus L 2 plus L. So these are the value of quantum number associated into hydrogen atom. And this all thing, remember, why we are using the Dirac notation, this is so important into the quantum mechanics, because you know this is the very complex function, very complicated function, not complex function. It is very complicated function. So unnecessary doing the calculation, we just want to avoid unnecessary doing the calculation. So what we will do, we will just write this all thing in term of kit. And what is this kit? This kit is identified as N L M. That's it. This is the kit NLM, where n is identified as principal quantum number. We will discuss why it is called principal quantum number and all these things. So n is basically divided, known as principal quantum number. L is known as orbital quantum number, and m is magnetic or azimuthal quantum number.
Sir, here M range is minus L to plus L.
Yeah, माइनस एल टू प्लस एल, यस माइनस एल टू प्लस एल, यस वो तो लास्ट टाइम किया था एंगुलर मोमेंटम में, ठीक है. M will be minus L2 plus L. Yes. So this is magnetic quantum number. So let's try to just, I am giving you one or two Laguerre polynomials such that you can just remember. This is also not important that you have to remember all these polynomials. They will never ask this thing, but yes, at least you have to write all these function. At least you know what is all these function. So let's go for some particular value of wave function. So at least we will go up to n is equal to 2. So what is will be R10? What is R10? Means L is equal to 1. Sorry, n is equal to 1 and L is equal to 0. That is n is equal to 1 and L is equal to 0. The value is basically 2 by a to the power 3 by 2 and a naught to the power 3 by 2 and e to the power minus r upon a naught. And what is a naught? A naught is basically Bohr
Radius.
radius. Yes. And all this thing you will do also into atomic physics. So I am not doing this thing because same thing you are just going to do this thing. So what will be energy associated to this? What will be energy associated to this particular radial wave function? What will be energy associated to this?
Minus
minus
Can
13.6.
anybody tell me?
minus
Minus 13.6. That is your ground state. So this will be also minus 13.6. This will be minus 13.6 electron volt. This is in the electron volt. Okay. Now, so for L is equal to 2, how many radial part is there? Can you guess how many radial part is there? R2 1 will be one radial part and R20 is the another radial part. So this will be, that is n is equal to 2 and L is equal to 1. So what will be this value? This value is 1 upon 24 a naught to the power minus 3 by 2 r upon a naught exponential minus r upon 2 a naught. So this is R21. Similarly, we can go for R20. So similarly, we can go for R20. That means n is equal to 2, L is equal to 0. And this value is equal to 1 upon factorial 2, A naught to the power minus 3 by 2, 1 minus 1 by 2, R naught by, sorry, R upon A naught, exponential minus R upon 2 A naught. So this will be your radial part of wave function. So you can see this is how much complicated. So there is no need to remember all this thing, okay? No need to remember. If examiner will give you, he will give what is your radial part of wave function, or he will give the problem in R20, R10, this kind of. So similarly, you have R31, 32, this kind of situation you have. And what will be the energy associated to these two? Minus 3.4 electron volt.
सर
Now you can
R1
see.
R10 में माइनस e की पावर माइनस r by 2 यूनिट आएगा ना?
नहीं, A naught. Yes, good question. Here is A naught. Here is 2 A naught. Here is 2 A naught. अगर 30 से लेके जाएंगे तो क्या होगा? E to the power minus R 3 A naught. Okay? Are you getting this thing?
Yes sir, yes sir.
Yes, sir.
Okay.
है ना? सिमेट्री को देखने की कोशिश करो. So please. So nth state में suppose I will write Rn and let the L part is proportional to e to the power minus R n A naught. Okay? In fact, you can write this wave function something like this also. You can write your wave function something like this. R n L m R theta phi is equal to Laguerre polynomial n and L R y L m theta and phi e to the power minus R n A naught. Okay, that is much better. This is weight function. This is weight function associated to the hydrogen atom. Due to this function, the hydrogen atom have a exponentially decaying nature as a wave function. That R tends to infinity, it will go to decay, such that it will become a square integrable. So, but I am just going for the examination purpose. And this thing is basically known as NLM. And the solving different type of problem, you need one integration. That integration is very important. You have to remember what will be gamma n. And this will be 0 to infinity. Gamma n is 0 to infinity. E to the power minus n minus 1. E to the power minus x dx. This is your gamma n. And this value is equal to factorial n minus 1. So what will be the power? That will be the factorial part. So always try to remember this thing. This is the main tool. You have to go for it and you can just go for it. You can just use this integration again and again. So if you have any doubt or any confusion into notation, just ask me. Just understanding of the notation is the most important thing. Then everything is cakewalk. Don't worry. Are you getting this thing?
Yes, sir.
So the
Okay.
gamma integral formula
Huh.
is it e raised to n minus 1? Is it x raised to?
E to the power minus x.
So the first term,
minus n
Yeah.
minus 1. Either you can write this one.
Sir, it's
Mhm.
x power and
That should be
Oh,
x to the power n.
sorry, x to the power. Sorry. That will be x to the power. Or either you can write this thing also 0 to infinity e to the power minus, x to the power minus n, e to the power minus x, dx is equal to gamma n plus 1. This thing you can also remember. I used to use this thing, that is factorial n. So leave the n minus 1 part. You can also remember this one. Okay. So sorry, this is x to the power minus n minus 1. Okay. Okay. So let's go for uh, what is physics behind this. So just I am going to discuss all this thing. So you can see that energy is dependent on the radial part of wave function. Okay. And n is the principal quantum number which will be responsible for the energy. Now, so what is my V effective? If I will write my V effective, that will be L into L plus 1 h cut square upon 2mr square minus E square upon 4 pi epsilon naught R naught. So when you will plot this V effective, and remember, we have already plotted this V effective into classical mechanics. So this V effective is nothing but something like this. Okay. And you can see the bound state is for the negative energy. So what will be minimum energy? This is for n is equal to 1. And this energy is minus 13.6 electron volt. This is for n is equal to 1. Next level is all about minus 3.4. This is for n is equal to 2. And next level is something like this. That is for n is equal to 3. So what you can see, the energy eigenvalue is the discrete. And suppose electron is in your ground state, that is n is equal to 1. And if you want to just ionize it and you just want to give the minimum energy such that it will become unbounded. Ionization means what? It will become unbounded. So how much energy you should give to the electron such that it will become unbounded is the ionization energy. So what will be that energy? The E ionization is basically the final energy is EF minus E ground state. And what is EF? The final energy EF, the minimum energy for which it is become unbounded is the zero energy. So that will be 0 minus what will be Eg is equal to minus 13.6 electron volt, and this will be 13.6 electron volt. So what is the ionization energy of the electron when it is in ground state of hydrogen atom? That will be nothing but the 13.6 electron volt, means an electron will just start here and it will land here, and this will be the energy. If you will give somehow energy as 13.6 electron volt, it is just going to ionize, or it is just going to unbound it. So ionization is all about the minimum energy for which electron will be unbounded. And you can see all negative value of energy will be bounded, but all energy are not allowed. Rather, some discrete value of energy is allowed, and this is the energy of hydrogen atom. We have seen this will be written as minus 13.6 by n square electron volt. So we have to use all this concept, and then we will we will just try to figure it out how much up to which level we can solve the problems. And you can see that we can solve more or less every problem of the hydrogen atom without knowing anything, only with the help of simply gamma integral and in a Kit and Bra form. So let's go for solving the problem. And yes, psi n dash l dash m dash psi n l m, or you can write n dash there. N dash l dash m dash is equal to delta n dash delta l dash delta m dash. So any one will be different from the another part, will be always zero. So let's go for this problem. The state of hydrogen atom, the state of hydrogen atom is given as, or the psi is given as in form of hydrogen atom. The psi is given as root 1 by 6 phi 1 0 0 plus root 4 by 6 phi 2 1 0 plus root 1 by 6 phi 3 1 1. Suppose, or let's say 3 1 minus 1. This is much better. Minus 1. Suppose you will measure energy. First, if energy is measured, and this will be in a form of kit. If energy is measured, what will measurement? With what probability? Second, if E naught is ground state energy, find the expectation value of energy E. Third, if E naught is ionization energy, find expectation value of energy. And fourth, if L square is measured on state psi, what will measurement? With what probability? If Lz is measured on a state psi, what will measurement? With what probability? Same thing. What will measurement? With what probability? So just we will do each and everything from this problem without solving any differential equation or without doing any integration. Let's try to go for this. So let's do first part for the energy, and then we will go for L square and Lz. So should I start the solving problem?
Yes, sir.
Okay. So when energy, so we have to recognize N, L, M. So what is phi N L M? Phi N L M is eigenvalue, sorry, eigenfunction, or that is the energy eigenfunction for hydrogen atom. So we have to recognize. So what will happen? The value of N is equal to 1, here N is equal to 2, N is equal to 3. So what you will get? The probability of N is equal to 1 means probability of getting energy minus 13.6 by 1 square, and that will be what, 1 upon 6, because this is normalized. And what will be measurement? Measurement is minus 13.6. So energy E1 is equal to minus 13.6. What will be second? You will just measure n is equal to 2. So n is equal to 2 is equivalent probability of measurement minus 13.6 by 2 square, and that will be 4 upon 6 or 2 upon 3. And what will be energy you are going to measure
minus
is
3.4.
E2 minus 3.4. Very good. And similarly, we will go for probability of measurement n is equal to 3. N is equal to 3 means I am talking about this state, and that will be
13.6 upon
minus 13.6 by 3 square. What
1
will
by
be this
6.
value? 1 by 6. So what will be E3? E3 is
1.5.
minus 1.5, isn't it? Check कर लो एक बार, आ रहा है क्या?
Yes, sir.
And these all are in electron volt. Don't worry. This is in electron volt. So now this is over. But second and third question, and this will never come into your exam. This is very simple. Okay. But the second and third question is very interesting. Why it is interesting? Because you have to understand what is relationship between ground state and first excited state. So what will we expect if E naught is ground state? If E naught is ground state, means minus 13.6 is equal to E naught. Please remember this thing. If E naught is ground state, means minus 13.6 is equal to E naught. And then what will be average value of E? So first what you will do, you will write average value of E in term of number, then you will put E naught. That will be the best idea that you can do it here. So what will be happen? Expectation value of E
1
is
by
equal
6.
to minus 13.6. Please मुझे बोलने दो है ना, जब मैं कहूँ तो बोलना. That is into 1 by 6 plus minus 13.6 by 4 into 4 by 6 plus you can have minus 13.6 into by 9 1 by 6, isn't it? So this is the thing. And please, what is E naught? E naught is the ground state energy in the second problem. So what I will do, I will put minus 13.6 electron volt as E naught. So this is very interesting. So what will be your average value of energy? The average value of energy is E naught by 6 plus E naught by 4 into 4 upon 6 plus E naught upon 9 into 1 upon 6. So if you want, you can just calculate it. So this and this will be cancel out. So this will be E naught upon 6 plus E naught upon 6 plus E naught upon 9 into 1 by 6. So you have E naught upon 6 as common, 1 plus 1 plus 1 upon 9. So you can write 9 plus 9, 18 plus 1, 19. So 19 E naught upon 54. If I am not wrong, I think this is the answer. Okay. But in a second problem, but in the third problem, and this is the very tricky one. They have given that E naught is the ionization energy. So what is E naught? E naught is nothing but the ionization energy, means what will be, so what will be E naught? E naught is actually plus 13.6 electron volt. So for expectation value of energy will always remain same. in term of number. Please, you have to keep in mind the expectation value of energy will always remain same in term of number. So what I have to do it here, I have to put not minus 13.6 as E naught, rather I have to put E naught as E naught. Minus 13.6 in this place of minus 13.6, we have to put 13.6 electron volt as E naught. So let's try to figure it out. What will be answer? Can anybody give me what will be answer of C part? What will be answer of C part?
In node by 6.
Mhm.
So
What
same
will be
as
answer of?
B.
Just you can replace this
Minus.
as 19 upon 54 into minus
Minus
E
E
naught.
naught.
That's it. And you can just check it. Here E naught is positive, so that is same value. And here E naught is negative, so that is same value. This value is actually what? 19 upon 54 into minus 13.6. And what is this value here? 19 upon 54 into minus 1 is already there, and that will be 13.6. So both are, and all three are same number. So you can see either they will ask you into ionization energy, or they will ask in term of ground state energy, or even they can ask you this thing is a first excited state energy. What you have to do? The expectation value of energy will always remain same. You just convert accordingly. So it is the best advice to you. First calculate in term of number. First calculate in term of number, and then you can just put which are the most suitable variable. You can just use it here. Are you getting this thing? Sorry, sorry. Where? This one. आपकी आवाज नहीं आ रही है. आवाज नहीं आ रही है, बिल्कुल नहीं आ रही है. देखो सेकंड क्वेश्चन में मैंने ई नॉट को ग्राउंड स्टेट कहा था. सो ई नॉट की वैल्यू क्या थी? माइनस 13.6. एंड थर्ड प्रॉब्लम में मैंने ई नॉट को आयनाइजेशन एनर्जी कहा था. आपको एवरेज वैल्यू ऑफ एनर्जी देनी है इन टर्म ऑफ आयनाइजेशन एनर्जी. सो व्हाट इज आयनाइजेशन एनर्जी? दैट विल बी प्लस 13.6. आर यू गेटिंग दिस थिंग? लेकिन एवरेज वैल्यू ऑफ एनर्जी तो हर टर्म में सेम ही आनी चाहिए ना एज अ नंबर.
सर ये कह रहे हैं आपने -1 रखा है यहाँ पे, और ये
कहाँ माइनस वन रखा है?
-1 सर ये रखा है आपने 90
अरे क्योंकि इसको मैंने पॉजिटिव रखा है, क्योंकि ये पॉजिटिव है, आयनाइजेशन एनर्जी है ये.
हाँ सर यही पूछ रही हैं.
आप ये जो लिखोगे एवरेज वैल्यू ऑफ एनर्जी, ये अगर मैं लिख दूं तो ये तो गलत हो जाएगा ना. आपकी एवरेज वैल्यू ऑफ एनर्जी तो नेगेटिव आनी चाहिए. दिस इज योर आयनाइजेशन एनर्जी. आयनाइजेशन एनर्जी को ग्राउंड स्टेट एनर्जी में कन्वर्ट करने के लिए क्या करना पड़ेगा? यू हैव टू पुट द माइनस साइन. And best thing is that first you will do with your number, and then accordingly you can put it. If it is ground state, then minus 13.6 will be your E naught. If it is ionization energy, then plus 13.6 will be your E naught. But the number will be same. Are you getting this thing?
ओके सर.
So it is very confusing. हर बार एग्जाम में confuse करता है इस तरह के क्वेश्चंस. Now let's go for L square and LZ. So if L square is measured, here L is equal to 0, L is equal to 1, and L is equal to 1 here. So what will be measurement? So probability of L is equal to 0 means probability of measurement 0 h cut square, and that will be 1 by 6. And probability of L is equal to 1 means probability of measurement of 2 h cut square that will be, here you will also get 2h cut square, here you will also get 2h cut square, and what will be value? That will be 4 upon 6 plus 1 upon 6, that is 5 upon 6. Lot of time this question have come into your exam, this type of question. When you have same measurement, you will add the probability, so keep in mind. So there may be possibility even n is different in every state. L can be same, sometime m can be same. For example, for next problem, the probability that getting m is equal to 0. So for probability you are getting m is equal to 0. Here you will get the m is equal to 0. Here you will get the m is equal to 0. Means probability of getting 0 h cut is all about 1 by 6 plus 4 by 6 is equal to 5 by 6. And second, probability as m is equal to -1, because either you will measure 0 or you will measure -1, and that will be equal to probability of minus h cut is equal to 1 by 6. So you can see how we can use this quantum number to understand the hydrogen atom. So only if you have all the the all property of quantum number of hydrogen atom, you can easily work with this. Very simple. So if you have any doubt, you can just ask me. Otherwise, I will go for next level. Okay. So let's go for next level of problem. So, second question. If radial part of ground state of hydrogen atom is a e to the power minus r a naught, find, so you have to calculate lot of things, find value of a, find value of a such that r is normalized, b, plot radial probability density versus r, and c, find most probable distance and d, write down expression for total wave function. E, find the expectation value of r square 1 by r. F, find the expectation value of x, y, z. G, find the expectation value of x square, y square, z square. So what we are going to do? We are going to solve the all different problem given in the Griffith, and all are unsolved problem. So every problem is a different problem. I have just taken into one problem. Okay. So don't think this is one problem. This is 7 and 8 problem. Not 7 and 8 can have this, all are different. Okay, but look at how quickly we can solve each and everything if you know the basic concept. So I hope just you can get all this thing. Okay, don't worry. Let's go for step by step each and everything. So this is the radial part. A e to the power minus r upon a naught. For the normalization condition, you have to use mod r square dr. Please, 0 to infinity. Remember in last class, that must be equal to 1. So what will be this integration? This integration is r square e to the power minus 2r upon a naught dr must be 1, 0 to infinity, that is mod a square. I am doing one integration, and next time what you will do, you will just directly write this, what is the value of integration. What you will do, you will just put 2r upon a naught as t. So what will happen, r is equal to t a naught by 2 and dr is equal to dt a naught by 2. Are you getting this thing? So this is dt a naught by 2. So let's put all this value here. So mod a square, and when you are going for the integration, the r is equal to nothing, t a naught by 2. So this will be a naught by 2 whole square t square. And here e to the power minus t and dr is equal to dt a naught by 2 must be equal to 1. So what you will see this a naught by 2, this number, reciprocal of this number will come outside with one more power. Here is power is 2, so it will come outside that power is 3. So you can just look at this particular thing. Mod a square, you can take here, that is a naught by 2 whole cube integration 0 to infinity, that is t square e to the power minus t dt, that is nothing but the factorial 2.
2.
Isn't it? So just we will do, just you will watch the integration and you will give the answer. Isn't it? So here it is r square, so here is a naught by 2 to the power cube. So what you have mod a square a naught by 2 whole cube 2 factorial 2 is equal to 1. So a will be,
2 upon infinity cube.
that will be 4 upon a naught cube to the power 1 by 2, isn't it? That will be much better. You can write 2 upon
A naught
a
cube.
naught to the power 3 by
2.
simple. And we have just seen also that this is the exact value. So this is your normalization constant of radial part. Are you getting this integration? Because I am just doing at once, and next time I will just write directly. Okay, so let's go for this. So what is my radial wave function? The radial wave function is equal to 2 upon a naught to the power 3 by 2 e to the power minus r a naught. So what will be radial probability density? So radial probability density is rho r. You can write mod r square into r square. Lot of people are just doing mod r square. This is blunder. Radial probability density is mod r square, r square. This is your radial probability density. So what will be this value? This value you can write 4 upon a naught cube e to the power minus 2r a naught into r square. This is your radial probability density. And when you are going to plot this, so this is rho r versus r. When you are going to plot this will be something like this. Okay, this is like something like this. And this is the maxima value, and maxima value is something at a naught. So how you will get the maximum value? Simple. The third question. The d rho upon dr must be equal to 0. So you have to put this particular thing. I am just keeping constant. You will just put d upon dr e to the power minus 2r upon a naught r square must be equal to 0, and you can figure it out. Just you can differentiate it. That will be 2r e to the power minus 2r upon a naught minus r square, and this will be minus 2 upon a naught e to the power minus 2r upon a naught is equal to 0. You can take e to the power minus 2r upon a naught as common, and r will be also common. So 2 will be also common, and then you will get 1 minus r upon a naught. So there will be plus sign here. There will be plus sign. Okay. So this will be equal to 0. So you can easily get r is equal to a naught. So this is the maximum probability. So at r is equal to a naught, you have maximum probability. And you have also learned in your school days that where is the maximum probability that you can find the particle. So yes, it is at r is equal to 0. Okay. So this is the first set. And what will be the total wave function? What is total wave function? This is my third one, or C part. So are you comfortable up to this?
Yes, sir.
Okay. So let's go for the C part. The C part, we have to write the total wave function. The total wave function psi 100. And what will be psi 100? You have to write r10 y00. And we have calculated r10. What is this thing? This thing is 2 upon
A naught keep
a naught 3 by 2 y00 and e to the power minus r upon a naught. And what is y00?
1 upon 4
Is
pi
1 upon root
and
4
root
pi.
pi.
Isn't it? So if you are using this expression, and this expression will come psi 100, this expression means you have 1 upon pi a naught cube to the power 1 by 2 e to the power minus r upon a naught. If you are using this expression, means what is variable? Variable is r, theta, and phi. Always keep in mind. If you are going to use this expression, this is the your variable. Okay. So we have done the first part of this, and lot of thing will come into. I think we should go for next class because time allotted is over. Okay. So second part in tomorrow's class, I will do some more problem of hydrogen atom, and you will see that is more than enough for the hydrogen atom. You can go for any examination, you can get this sort of question, and you can easily solve it. So just focus what we need to do on a calculation basis, not in a story basis. Okay. So tomorrow, I think first 15 minutes I will just go for hydrogen atom, and then we will just go for LS coupling and all about thing. We will just try to finish degeneracy and all this thing in tomorrow's class. Okay. So tomorrow we will going to finish the hydrogen atom. Okay. So if you have any doubt, then you can ask me.
सर जो बाई 00 की वैल्यू निकालते हैं सर,
हम्म
सर वो सर बहुत लेंथी थोड़ा होता है, कॉम्प्लिकेटेड। सर डायरेक्टली याद
कहाँ
करने
कॉम्प्लिकेटेड होता है?
सर डायरेक्टली
जैसे
याद करने में भूल
y
जाते
जीरो जीरो तो 1/√अंडर 4 पाई है, और क्या
हैं।
होगा?
सर इससे ऊपर जाएंगे तो हम 20।
उतना तो याद करना पड़ेगा, बट तुम्हें जरूरत नहीं है याद करने की, ठीक है?
ओके सर।
आप ये देखो कि देखो मेनली पर्पस क्या है? पर्पस है चीजों को समझना और करना। याद करना आपका कभी भी पर्पस नहीं है हायर लेवल पर। ओके, सो आप रिकॉग्नाइज कैसे करोगे उसके बारे में मैं कल बात कर दूंगा, ठीक है?
ओके
एक फाइनली एक्सप्रेशन देख करके कैसे रिकॉग्नाइज करोगे चीजों को, कि L की वैल्यू क्या है, M की वैल्यू क्या है, N की वैल्यू क्या है। दिस इज इंपॉर्टेंट क्वेश्चन, इजंट इट? सो व्हाई वी हैव डिराक नोटेशन ना, अदरवाइज हम डिराक नोटेशन क्यों पढ़े जाओगे, हमें वही करना था तो। ओके, सो आपको कभी भी याद करने की जरूरत नहीं पड़ेगी, कभी भी किसी भी एग्जाम में ये नहीं आता है कि आप इसको रिकॉग्नाइज करो। व्हाट यू हैव टू डू, यू हैव टू रिमेंबर, यू हैव टू जस्ट सी व्हाट विल बी योर क्वांटम नंबर। ओके,
ओके सर।
वो मैं कल मैं मेरा डिस्कस करना भी है, बिकॉज एलएस कपलिंग के बाद मैं सारा एक साथ लेकर के डिस्कस करूंगा, स्टार्टिंग फ्रॉम एंगुलर मोमेंटम अलजेब्रा टू up to this hydrogen atom and next level of L and S, everything. Okay,
थैंक यू सर।
okay,
Thank you, sir.
Thank you, sir.
thank you.